Good evening everyone, and welcome along to this supplementary lesson. Today I am going to touch upon the exception handling in Java, and in relation to that I'm going to go over question 2 from SCOM 7013 and this question should highlight some of the pitfalls and some of the various aspects of the exception handling in Java that needs to be understood. So the first thing I want to touch upon, as I have done in the previous class, is to look upon the exception hierarchy. And as you can see here, the exception hierarchy is split up into two separate sections. Let me just click inside my pen here. The throwable and the checked exceptions, which incorporates all of those in yellow, and the ones that I want you to remember basically are the exception and I guess the IO exception, and then all of the unchecked exceptions would be incorporated in terms of the runtime environment and all its subset as well. And I do recall the mentioning in a previous lesson, it would be no harm to memorize these, and I have basically a method to do that, which is the Terrycan. Sorry there. So it's based on the throwable, and then we have exception. I guess you can incorporate IO exception, and then we have error, which is here, and then we have the runtime exception, and then we have the index out of bounds exception, Terrycan, and we have the illegal arguments exception, and the illegal state exception, and then I'm talking about the arithmetic exception and the null pointer exception. So that's my method of memorizing the exception hierarchy, and it would be no harm to maybe have an idea about that if you're incorporating exception handling in your test. Now, as well as that, the throwable is also a checked exception, and so just to confirm, the throwable, the exception, and all of the yellow, they're all checked exceptions. These need to be incorporated into a try-catch method, or the method upon which where the exception is being thrown, needs to explicitly state that it's throwing an exception. So there's two rigid protocols there for the exception handling. So let's go to question 1, as I said. So question 1, let me just open up question 1 there. I'll just find it. Question 2, my apologies. Let me go into question 2 there, and let's just scroll down. Now I'm moving on to question 6, which was the first one that caused difficulty. If you define a try block, you can pair it with a matching catch block, or finally, or both. If you define a try block, you can define. So my first question would be, and the first question you need to ask yourself would be, in relation to the question 6, if you define a try block, you can pair it with a matching catch block, finally, or both. Now, that question depends on whether the exception is checked or unchecked. So if it's checked, then that is not true. If it is unchecked, then it is true. So let's go and test that for a checked exception. If you define a try block, you can pair it with a matching catch or finally block or both. So let me just go into my text field. So here I have my method here, which I'm going to test. I'm going to comment out the try block, and I'm going to explicitly throw an exception in this method. Okay, so if it's in a try block, as the question asks, then I'm going to remove and just put in a finally block. So I have my finally and system.out.println inside finally block. And I'm going to explicitly throw this exception now, which is a checked exception, in here. And I just need to test this out. And it is, as I stressed in previous examples, it is essential that you practice exam questions yourself in terms of using the compiler. So let me go and just check one thing there before I continue. I want to go in to check that. Yes, that's perfect. So let me just go back in here, and as I said, I just need to create an instantiation of this test class to test my method called TC, and I'm referencing a new object, which is my test class. And then inside here, I'm going to paste that, and I'm going to call it method A. I'm going to call method A. Save that. Now, what should happen in this situation? Well, let's have a look. The object gets created, and then there's a reference called in relation to that object, which calls this method here, which jumps in here into this throw clause, which throws this checked exception. And according to the question, according to the question, it states we don't need a catch when throwing an exception. And I'm going to test this out now. So I only have a finally clause. And I'm going to tell you now that's not going to work. Why? Because all checked exceptions must be wrapped in a try catch block. That's rule number one. Or rule number two, the method, this is only for checked exceptions now, the method throwing the exception needs to declare that it may throw an exception, a checked exception. Well, it can declare that it can throw any type of exception, but in this case, checked exception. So I'll explain further in case you get confused. These are just the general rules. So in this particular instance, I'm testing question 1 must be wrapped in a try catch block, and according to according to my situation here, I don't have a catch block, so therefore this should be a compile error. So let's try this out. So if I go down here and do my compilation, and there you have a number of exceptions. Let me see if this is the So getting back here, I just want to test out the class without the try block, and let's see if it compiles and runs. And there it does. And if I run it and just put in sample system.out.println, undo system.out.println inside method A, so if I paste this here, if I compile that, if I run that, as you can see, the class runs perfectly. And now let's test it with our checked exception. So I shall remove that. Oh, and so what's going to happen here is, because of our rules, this is a checked exception. It's not being caught. And number two, the method that's throwing the exception is not declaring that it throws the exception. So therefore, the compiler is going to say, hang on a minute, we have a checked exception, nobody's catching it, compiler. So let's try that, compiler error. And there you go, you have 10 errors, but the main aspect of it basically is it's not pointing you in the right direction. It's just stating that there's a checked exception that's not being thrown. If I remove this checked exception, and if I compile with the try finally, it's still stating that there's an error in relation to the try finally block. So a try must be matched with a catch block as well. If it's a try and a finally, it will throw an exception. It'll throw a compiler error. Does that make sense? So now let me move on to the next aspect of it. If I incorporate a catch block, and catch exception, and if I declare that I'm going to throw a checked exception, system.out.println, exception has been caught. So what's going to happen in this situation? Let's have a look. In this situation, the method gets called from here, which jumps in here, which throws an exception, which gets caught here. This is going to be printed out, and then we jump into the finally block, and this gets printed out, and then we jump down out of the code, down to this block, down to this method, code ends. So the exception has been caught, and everything the code should close as normal, not unexpectedly. So let's try this. So if I go in here, and it's declaring that I have something is expected. Try catch finally. So getting back to my question here, I had a syntax error up to this point, and I've discovered what the syntax errors are. And let me just show you where they were. I had a opening and closing bracket here, and there should be no brackets in the finally. So if I compile this now and run it, what happens is, as I said to you before, the TC gets called, which jumps into the try, nothing gets called in there, jump into the exception. It doesn't jump into the exception because there's no exception thrown, so it jumps down into the finally, it prints this, and then it jumps down here into the end block, returns then to the method, so it jumps down to line 46 and then 49, and the code completes as planned. And that's the whole idea of exception handling. You want to make sure that the code does not destruct as not planned. And let me give you an example of just an overall schematic view of why this is important. So if I go into here and I type here, so we have a situation in the real world where you have, say for instance, a rocket system and it's taking off, and you might have in the code a sequence of events, sequence 1, sequence 2, sequence 3, in relation to a rocket system taking off. So I suppose once all of those are checked, if there is a difficulty in relation to a rocket system, then it will be a case of ensuring that the exception is caught. And if it is caught, that means, in terms of our code, program starts if there is an unexpected error, then we catch the error and we resume to a normal completion. And this is very important. In a system where, so that's normal, planned shutdown. When the system ends. But in a situation where you have program starts, unexpected exception occurs, exception is not caught, system shuts down unexpectedly. And that's the thing that we want to ensure doesn't happen. We don't want this happen, and so the solution is exception handling. So that's basically it. We don't want a catastrophic shutdown, and an example of a catastrophic shutdown would be the Ariane space rocket in the late 90s. The situation with the Royal Bank of Scotland. Royal Bank of Scotland system there, where the RBS, which was affiliated to the Ulster Bank, last year I believe, it was a situation where people weren't getting paid their money. So again, exception handling was an exception was not caught in that particular situation, and the computer basically crashed catastrophically. So this is just an overall view as to why exceptions are important. So let me just jump back into the code again. So now, getting back to it, an exception needs to be placed. If an exception is thrown, let me just throw this exception here now. It's going to compile and run as normal, and the exception is going to be caught, throw exception. And here we have a situation where again it's a syntax error. I compile, throw exception. Your next question should be, what is the problem there? I want you to think about what the problem is. It's on line 16. What is the problem there? You should have guessed it by now. Throw new exception. So if I compile this, and there we are. And again, I'm just going to briefly run it. And as you can see, it runs the exception. The program runs, calls this method, which jumps into the try block. It throws this exception. The exception gets caught here. I print this out. I jump into the finally block because I always jump into the finally block. It always gets run. And I print this, and then I jump down to line 45, line 46, 47, 48, and program ends as planned, as you can see here. So now I've described an exception where it should be caught. If, as the question stated, I have a situation where you can pair it with a matching or finally, again, that's dependent on whether the exception being thrown is a checked or an unchecked exception. So if I remove this, now we have a situation where the exception is not being caught. The method, as well as that, the method is not declaring that it explicitly throws an exception. So therefore, there will be a compiler error. Let's try this and see if that is the case. And there we have it. Exception must be caught or declared to be thrown. So again, in answer to that question, that's false because we haven't got all of the information in question. If, on the other hand, now I've explained so far that an exception, a checked exception, we're only talking about checked exceptions now. Unchecked exceptions don't need to be placed inside the try block, and the method that throws the unchecked exception doesn't need to declare that. We're only explicitly focusing in on checked exceptions. And again, you need to know checked exceptions are throwable exception, IO exception, and all of the exceptions, shall we say, user-defined exceptions that inherit from exception. Let me go back into the exception array. So the only exceptions that need to be placed inside a try block are the only exceptions that need to be placed inside a try block, try catch block, where the exception needs to be explicitly caught, are exception, all of the subsets of that, exception, all of these subsets, and all of the user-defined exceptions that are a subset of exception. And I've also have to include the throwable. So now we've explained that. Now what I want to do is, I want to explain the second part of the rule then. Second part of the rule states that if it is a checked exception, we can leave out the try block, which I'm going to explain next, and state that the method that throws the checked exception, you need to state that it will throw an exception. So that's the syntax more or less. Method throws exception. So now I'm going to explain the second aspect of how a checked exception can be handled. I'm going to switch this off, go back in here. So now, let me just remove this for the moment, and let me state that in this particular instance, throws new exception. So now, in this instance, I'm declaring that a method A throws a checked exception. And what you should be stating is now, you should be thinking like the compiler. You should be saying, well, hang on a minute. There are two aspects of throwing a checked exception. Number one, is it placed inside a try-catch? No. So the first thing, let me just write this down here now. So number one, you're thinking like the compiler. Is it inside try-catch exception block? No. Number two, which is what we're going to go on to next, does the method A declare that it throws an exception? No. Therefore, compiler error. And let's try that out there now. So if I run this, and here we have the problem solved. So if I declare, this is the second aspect of it. The first aspect I went through explaining how to catch a checked exception by using a try-catch block. So that's basically stating, let me just recap here for a moment here now. What I'm basically stating is, when I declare that it throws, if I incorporate this into a try-catch, now let me just go into the red there now. Maybe yellow, try yellow. If I'm declaring, if I'm declaring that a method, if I wrap this basically in a try-catch, new sorry for my writing there, but you get the idea. New exception, catch exception, E. What I'm stating is that this method is responsible for ensuring that the exception is caught. So this method is responsible. And it does if I've incorporated the try-catch and I put my exception inside that, wrap it inside it. Now, let's move on to the second aspect, which states the following. I'm throwing an exception, and now what I'm stating is that the method is going to declare that it may throw an exception. So what we're stating is so just getting back to, I just had to refill my paper, my smart paper. What I'm stating here is that this method may throw an exception. So therefore, this method does not need to be responsible, is not responsible for catching this exception. But what it's stating is anyone that uses or calls the method A will be responsible for catching or passing on that it too may throw an exception inside its code. Now, if you're a bit confused, let me just go back over and explain that again. So what I'm saying is, at the moment, I'm stating method A declares that it may throw an exception, and in this case, I'm just testing that by explicitly throwing the exception. So in that instance, this method A now is absolving itself of its responsibility in terms of catching this exception. That's the whole feature of incorporating this throws at the end of it. And so whatever method where this is, whatever method that uses method A is now responsible for ensuring that the message is caught or that it's passed on to the next person who's responsible. So let me just go in here. So my next question is, what happens is code starts, program comes up here, says method A, yeah, it throws an exception. So it throws the exception as normal. So then inside this main method, the question is, it should now be responsible for catching the exception that was thrown in here. And at the moment, it's not doing two things. It's not declaring, this method is not declaring that it throws an exception. And furthermore, it's not wrapping the method in a try-catch exception block. So therefore, there should be a compile error there. Because although the exception has been passed on, it's still not caught down the, shall we say, stack. So let's just try this out here. And there you have it. It's stating illegal start of expression. In other words, what it's stating is that the method is not caught. If I declare here that this throws an exception, I have another syntax error, so I'm just going to try to find out what that is. And I found what the problem was. And again, this is very, very important now in terms of an exam situation. I'm declaring that it throws an exception. And again, I had a little syntax error. And this is a good, cute question for an exam. You declare that it will throw an exception. So let me just run this now again. And here we have it runs. And I'm just going to comment this out here just to prove that. There we go. So that's the initial. It must be caught or declared. And as you can see, method A states that it may throw an exception, which it actually does. So method A is absolving itself of its responsibility in terms of catching this exception. And any method that calls this exception, in this case it's method, the main method, that should now be responsible for ensuring that this method A, the exception within method A, is caught. And it hasn't done that, so it throws an exception. And again, all you're doing basically is passing the buck down the line. When you explicitly declare throws exception, you're passing the buck down the line for whatever client code or method is going to use that to ensure that they catch the exception. And in this instance, the main method doesn't wrap the main method A in a try-catch block or declare that it throws exception. So it's going to throw a compiler error. So let me just uncomment that out, run it, and there we are, and run, and there we go. Although it still throws an exception, it's still a controlled exception being thrown, shall we say. Ideally, we would have the method not be, we would not have the main method throw an exception. But we would have the responsibility more or less inside the method A, wrapped inside a try-catch block. So again, I want you to take down notes for any questions that you have in relation to this particular lesson, and I want you to ask me at the next live session, which is this Wednesday, which is tomorrow, the 10th of December. So just to confirm again now, ideally I wouldn't want to have an exception, a main method throw an exception, because the main method shouldn't really be responsible for catching stuff. It should be the responsibility of wherever ideally the method is thrown, or any other client code. In this instance, I don't have any other client code, but let's assume you have a test class B. Let's assume you have say, a test class B, which calls this class, and inside your code you're going to have method B, and inside there try TC. Well, obviously we have already declared now an instance of it above, so I'll say test class TC1 equals new test class, and therefore I'm going to say TC1 dot method A catch exception E. So now again, this is on I incorporate the main method here to explain this, but in real terms, you're going to have other clients. So this would be termed a client code of the test class, and it's incorporating the client code here from test class in its particular code, and it's being responsible for ensuring that the exception is caught. Why? Because it's wrapped in a try-catch block. So that's basically it in terms of try-catch and throws. Just a quick recap again. When I have a checked exception, I will always have to wrap it in a try-catch block. That has to be the case. And if it's not, alternatively, I can declare that the method that is throwing the exception can declare that it may throw an exception by typing in throws exception. And that means that the responsibility is absolved from method A to catch the exception, and whatever client code that uses method A will be responsible for that. If the client code does not wish to catch that exception, then it can declare as well as itself that it throws an exception as well. And so whatever client code that catches, let me just go back in here now again just to explain that. So if I have, say for instance, test class method A may throw an exception. So then I have a client class, as I did earlier, test class B, and that has a method B, which has a call to method A. So that can either wrap the code in a try-catch, or it can declare itself that it throws an exception, and therefore absolving its responsibility. So in other words, if there's another method, or another class, test class C, that incorporates method B, that uses method B, then therefore that again can, shall we say, be responsible for catching the exception or throwing it. So we can move along through the code and pass the buck, basically, if we so wish, by pass the buck in terms of catching the exception. Alternatively, we can explicitly state anywhere, try catch block. And then the exception is called here, so the responsibility is here, or we could have incorporated here, try catch block, and so on and so forth. So I want you now, because this is the fundamentals of the exception handling, I want you to become familiar with this. And if you do have any form of question in relation to that, you must write it down and get back onto me to talk to me about that. So I think once I have explained the fundamentals, let me just move on there in relation to the other aspect of the. So if you write a method that declares that it can throw a compiler checked exception, you must also wrap the exception throwing code in a try block. And again, it's yes and no. If the accepted checked exception, you can explicitly declare that the method that throws the exception, if you write the code that declares it can throw an exception, yeah, then it can. So in other words, what it's stating here is that if you have a method, let's go back to our method A, and it's explicitly stating the following: method that declares that it throws an exception, and you must also wrap the exception. So if you write a method that declares that it can throw a compiler checked exception, you must also wrap the exception throwing code in a try block. Now, I suppose there's a yes and a no answer to this based on whether the exception declares that it throws an exception, and if so, you don't necessarily need to wrap it in a try block. However, if it doesn't explicitly state, if the method doesn't explicitly state that it may throw an exception, then you do have to wrap it in a try catch block. So again, just bear that in mind. In this particular instance, I would say yes to I would make an assumption that what they mean is that the method is not throwing exception. Again, see clarification about that from the lecturer in the exam. So that's that. Now, the main method in your program must handle all unhandled exceptions thrown to it. And basically the answer to this is yes. As I went earlier, I gave a situation where method A throws an exception, jumps down here, and anything that's not caught, you must either wrap the code in exception in the try catch block or declare that that throws an exception in itself. So the answer to that is true. A single try block can have many catch blocks. Yes, that is the case. So let me jump back in here and let me incorporate Java try catch. So here we have this, and you can have, oh, sorry. Now, just going back to a hierarchy, and this is important. So let's assume that it's throwing an exception here. You might have multiple separate different exceptions being thrown within this code, because there could be many different lines in the try block. So there could be multiple different exceptions thrown. So it's important that you handle all of those exceptions. Now, my next question to you is, if I didn't have any exceptions being caught here, so this is a checked exception. If I removed this checked exception and had it as, let's go back to a hierarchy there, and had a class cat arithmetic exception, and I had an illegal state exception, then the compiler will throw an error stating that the exception hasn't been caught. So it's a try catch, but for checked exceptions, you have to explicitly state the exception that's being thrown, or state the super type, the parent type of the exception. Again, I want you to ask me the questions in relation to any aspect of that. But getting back to that question, yes, you can throw multiple different exceptions. So if I go back into the class hierarchy, there is a rigid, shall we say, structure in relation to which exceptions can be thrown first. So what you would do is you would have the most appropriate exception at the top of as the first catch, and then the least. So if I wanted to throw a null, if my exception was being thrown, a null pointer exception, I would have that at the top, and then I may have a runtime exception, and then finally I may have an exception itself being thrown. Let me just go back into that there to explain it. So I have runtime exception. So there we have a runtime exception and then an exception. If I went about placing the opposite way around, then it should give a compiler error. Let me just do that again. And there we are. It's throwing up unreported exception. Right. So if I compile this, might give an error there now. Unreported exception, Java thrown. Runtime exception. So if I just remove this there, and if I just go back to my, now as you can see in this instance here, I'm doing two options. Again, it's one or the other. You either catch it or you throw it. Now you can explicitly incorporate the two. In this instance, I have this uncommented, and I declared it a thrown exception. And when you do that, that means the subclass must also catch it. But I'm going to explicitly catch this exception here, so I don't need to incorporate that. I hope that makes sense with everyone. And again, I just want to go back to the initial hierarchy in terms of and as you can see, there is a rigid structure. It's the on the top, on the child, it's the exception that's most probably going to be called first, is the one that should be on the top, and the least at the bottom. So if I remove this and put this down here, and run this, and there we are, runs perfectly, compiles perfectly. So let's move on there now again. You can have multiple different catch blocks. That is correct. A method can only throw one kind of exception, and that is false. As you can see, you can throw multiple different types of exceptions inside the code here. And we're on to 11. A finally block will run regardless of whether an exception is thrown, and that is true as well. And again, test it out. Again, watch the syntax. System.out.println. I am inside the finally block. And there we go. Perfect. So it does always execute the finally block, and you must be asking yourself the question next. Always anticipate what the questions are going to be. What is a finally block used for? It's used to release resource code. You don't want a situation where you have, for instance, opened a database or a file on the physical hard disk. You need to make sure that that gets closed down. Otherwise, there could be difficulties for the actual application itself that's running. Let's move back onto here. So that's 12 done. A try block can exist by itself without a catch block or a finally block. Let's try this out. I don't believe that to be true. Let's just try it. Now, technically speaking. So there we go. It must be matched with a try or a catch. Oh, sorry. Let me just go into that compiler error there. This is a very important point now. This is very important, and let me go into it. So at the moment, it gives a compiler error. It states try must be matched by catch or finally. Now, this is the fundamental only for unchecked exceptions. For checked exceptions, it must be matched with a try let's rub this here. It must be matched with a try catch and whatever the checked exception is. Okay, so if I declared that it was a runtime exception, and I'm going to remove that, I'm going to remove that, let me try this. There we go. So this is an unchecked exception, and therefore that is true. This is true here. But if it was a checked exception, then it wouldn't be true. Now, the order for which blocks never matters. That's false. I just explained to you earlier. You have to have the most appropriate exception being thrown at the top and the least at the bottom. And you have to refer to the most appropriate at the top, the least at the bottom. Okay? So you just place your exceptions up to the hierarchy. A method with a try block and a finally block can optionally declare the exception. A method with a try block and a finally block can optionally declare the exception. Optionally declare the exception. A method with a try block and a finally block can optionally declare an exception. The answer to that, let's go back into it. A method with a try and a finally can optionally declare an exception. So when I say declare, I mean in here. So can I optionally declare a checked exception? Let's try this. Yes, I can. So we are proving that it is. But if I declare a checked, I've just declared an unchecked exception. And as you can see, the assertion remains true. But if I declare an unchecked exception, in your vast knowledge now of coding, you would know that that is false. So that question is false. A method cannot optionally declare the exception. It needs to explicitly declare whether it is a checked or an unchecked exception in a try finally block. Runtime exceptions must be handled or declared. The answer to that is false. Runtime exceptions don't need to be handled or declared. Let's try this. If I remove all of this and I remove this, it will compile. But if you run it, obviously it is going to throw an exception. So, you need to make sure the principles again of what exception handling is. You don't want the code to crash unexpectedly. So, but from a compiler point of view, yes, it will compile. Runtime exceptions must be handled or declared, and the answer to that is false. But again, make sure you know that it won't run. It will at a certain point in time shut down the computer, shut down the application. Let's just see that run there. So it compiles, but it's not being caught, so it's going to throw an exception. Now what I'm saying there is that what I'm saying here is that what I'm saying here is that after this exception has been thrown here, then the code resumes. So I suppose in a situation where you have GUI and a window is open, and let's assume you have a button there, you press the button and it throws this exception, but still the program resumes back to a state that has not closed down the system. Does that make sense? So that's for unchecked exceptions. So that's basically it in relation to this particular example. I hope you review this. I want you to revise the questions. I want you to write up the questions for me in terms of the checked exception exception handling, what we went over. It is quite complex, but I hope I have demystified it to ensure that you have a better understanding now of checked exceptions, unchecked exceptions. With checked exceptions, you have to have them in a try-catch block or declare that the method that throws the exception declares that it explicitly throws it. In other words, that it may throw it. So the language is important. So that's more or less all. And thank you for